In this video, we're going to do some trigonometry review. So we'll talk about radians and degrees. We'll find values for common angles for cosine and sine, and we'll talk about the 6 trig functions and how they relate to one another. So we're going to start with a circle of radius r centered at the origin, so pictured there in the center. And when we talk about the radius, that's the radius of the circle, r, and that radius of the circle is the same at any point of the circle, centered at the origin 0, 0. So we know that an angle can be measured in radians or degrees. Let's talk about radians a little bit. So a radian is one radius of the circle. That's what a radian is. So if we take that radius r and we think of it as like a string that we can pull around and move around, and we took that string and we put it against the circle, then it would go about that far. So that's about one radius of the circle, taking a string of length r and putting it on that circle. So we could lay another little string of length r, where r is the radius, onto the unit circle. And so here is my question for you. If we wrap strings of radius r around the circle end to end, how many will it take to cover the whole unit or the whole circle once? So it might help to think about the formula for the circumference of a circle. So think if you can remember what that is and try to estimate how many strings of length r, where r is the radius, it takes to wrap around the circle of radius r. Okay, so you may recall that the circumference of a circle with radius r is 2 pi r, where r is the radius. And remember that an approximation we often use for pi is 3.14. We know that it's an irrational number that continues on and neither terminates nor repeats, but 3.14 is a decent approximation. So that means that 2 times pi would be about 6.28. So that tells us that how many times should the radius go around the circle? What is the circumference of the circle? 6.28. So it should go around 1, 2, 3, 4, 5, 6, and a little 0.28, ... So that means that it takes 2 pi radians to go around the circle once. Remember that a radian is just one radius of the circle. That is the unit of measurement that radian is. So going all the way around the circle once takes 2 pi radians, which we also know is 360 degrees. So 2 pi radians is equal to 360 degrees going all the way around the circle once. And that would also tell us that going halfway around the circle is half of 2 pi. So if we wanted to go just halfway around the circle, that means that this would be an angle of pi radians. So going halfway around the circle would be pi radians. Going a quarter of the way around the circle would be pi over 2 radians. So this is an angle of pi over 2 radians, a quarter of the way around the circle. And going an eighth of the way around the circle, that would be, let's see another color, that would be pi over 4 radians. So pi over 4 radians is going an eighth of the way around the circle, or 45 degrees. So we had pi over 2 radians is 90 degrees, and pi radians is 180 degrees. So that's radians and degrees, and that's what a radian is. A radian is one radius of the circle that it is on. So the fact that an angle of pi radians, an angle of going halfway around the circle, is equal to pi radians is also equal to 180 degrees gives us a way to convert between radians and degrees. So since pi radians is equal to 180 degrees, that means that if we wanted to find one or the other, we could, for example, divide both sides by pi to get 1 radian. So divide by pi, divide by pi. And 1 radian is equal to 180 divided by pi degrees. So taking 180 and dividing by pi, or dividing by an approximation, 3.14, tells us that 1 radian is about 57.3 degrees, so about 60 degrees or close to 60 degrees. And this gives us a way of converting any number of radians to degrees. So if we said, okay, what about pi over 4 radians? Pi over 4 radians would be equal to pi over 4 times 180 degrees over pi. So now our pi and pi cancel out. So this would be 180 degrees over 4, and dividing 180 by 4 would give us 45 degrees, as we know that it is. So we can do this anytime we want. If we want to figure out what is pi over 4 radians, basically we can just multiply by 180 over pi. Our pi's will cancel out. Similarly, we can go backwards. So since pi radians is equal to 180 degrees, if we want to convert the other way, we can divide both sides by 180, divide by 180, just by 180. And that means that 1 degree is equal to pi over 180 radians. So for example, if we were looking at 60 degrees and we wanted to convert that to radians, we could take this equation and multiply both sides by 60. So 60 degrees is equal to pi over 180 times 60 and radians. And so that means that 60 degrees is equal to pi times 60 over 180. We can radians, we can cancel our 6 with 18, and we get 3 on the bottom, and we can cancel the zeros as well, and so this would be pi times 1/3 radians, or pi over 3 radians. That's 60 degrees. So here are 2 quick examples for you to try. So try converting each of these and also drawing them on the unit circle where the angle is. So pause and try this out. Okay, so converting 150 degrees to radians, we know that we can just multiply by pi over 180. So 150 degrees is equal to 150 times pi over 180 radians. And so that's equal to pi times we can divide both the top and the bottom by 10. So 15 over 18 radians. And we can continue to cancel out. So both the top and the bottom are multiples of 3. This divided by 3 is 5, and this divided by 3 is 6. And so this is equal to 5/6 pi radians. So let's also draw that angle on the unit circle. That would give us 150 degrees. That's basically 30 degrees. So this is 150 degrees, and it's also the same thing as 5/6 times pi radians. Now to convert negative pi over 6 radians to degrees, I need to multiply it by the reciprocal. I need to multiply it by 180 over pi. So negative pi over 6 radians is equal to negative pi over 6 times 180 over pi degrees. And so the pi's cancel out. I'm left with negative 180 over 6 degrees, and dividing gives me negative 30 degrees. So negative 30 degrees, that's about there. Negative 30 degrees is the same as negative pi over 6 radians. Let's now talk about the sine and cosine functions for an angle theta. So here is our angle theta on the circle of radius r. The sine and cosine of that angle are defined by considering the point x comma y that intersects with the angle on the circle, and dropping down to find both the height of that triangle that's created and the base of that triangle that's created. And notice that the base of that triangle now has length x. It's the x value at that point. The x value at that point, x. So the base is length x, and the height is of height y, the y value at that point. Now the sine of theta is the opposite, the length of the opposite over the length of the hypotenuse. So here's our hypotenuse. And our cosine of theta is the length of the adjacent side length to the angle theta. So we've got x, we've got y, and we've got our radius, whatever that is. So this radius is the hypotenuse of the triangle. The value of y is the opposite side length to the angle theta, and the value of x is the length of the triangle that is adjacent to the angle theta. Now, something to observe is that the definition of sine and cosine only depend on the ratio of the side lengths for that angle theta. Since that ratio is preserved, sine and cosine only depend on the angle, not on the exact value of the radius. So that means that we can use a radius equal to 1 to simplify these formulas. So we're going to look at sine and cosine with the unit circle. Unit circle means a radius of 1 as opposed to a general r. And so now this is a 1 as the length of the hypotenuse. And that means that sine of theta is the length of the opposite side to the angle over the length of the hypotenuse. So that's y over r. So y over r, but now r is 1. And so that just simplifies to simply being y. And the cosine of theta is the adjacent over the hypotenuse. That's still a side length of x over 1. And that simplifies simply to x. So on the unit circle, the sine of theta is y, the y value when we drop down and make a triangle here. And the cosine of theta is simply x, the x value, the base, the length of the base of that triangle, the side of the triangle that is adjacent to the angle theta. So let's use that knowledge to find sine of theta and cosine of theta for some specific values of theta. Let's find it for 0 radians, pi over 2 radians, pi radians, and 3 pi over 2 radians. I'd encourage you to pause at this point and try to think about it yourself. So we haven't done any examples like this, but see if you can think of how you might find these values. Let's start by finding these values for theta equals 0. So when theta equals 0, this is just an angle of 0, theta equals 0, we have our triangle is really just a line, so it's not really a triangle at all. But what is the base of this? What is the x value? Our x value is 1. And what is our y value? Our y value is the height of that, which is 0. And so that tells us that since sine of theta is equal to y, sine of 0 is equal to 0, and cosine of 0 is equal to 1. Similarly, when we look at pi over 2 radians, we've got pi over 2 radians, pi over 2. We've got the opposite thing happening. So our y value is 1 and our x value is 0. So 1 for sine and 0 for cosine. When we're looking at pi radians, then we've got so this is pi radians. We've got an x value now, x value of -1. That's where x is on the unit circle. So -1 is what cosine is equal to. And the y value on that circle is again 0. And finally, when we look at new color, when we look at pink, when we look at 3 pi over 2 radians, here's 3 pi over 2 radians. We now have a y value of -1, so y value, that's sine, and an x value of 0. So there are sine and cosine for multiples of pi over 2 radians, just one go around on the unit circle. And we know that this goes, cycles on and on forever, so it cycles every 2 pi. So this is the same as what would happen for sine of 2 pi and cosine of 2 pi, and also for 4 pi and 6 pi and so on and on and on. And each of these will be the same value cycling every 2 pi. So if we add 2 pi or subtract 2 pi as many times as we want, we'll have those same sine and cosine values. To find sine and cosine of some other common angles, we're going to use the Pythagorean theorem. So the Pythagorean theorem tells us that for a triangle or a right triangle with side lengths A, B, and C, where C is the hypotenuse of the triangle, this formula holds. The sum of the squares of the two smaller side lengths is equal to the square of the larger side length. So let's think about it in context of our unit circle. So we've now got a triangle with side lengths x, y, and 1, where 1 is the hypotenuse. First of all, one really useful trig identity is that now we've got, x squared plus y squared is equal to 1 squared, the side lengths of our triangle. And what is x? Well, x is cosine squared of theta, cosine squared of the angle theta, plus y is sine of the angle theta, so that's y squared, sine squared theta, is equal to 1 squared, which is 1, and that gives us a really common trig identity right there, that the sum of cosine squared of theta plus sine squared of theta is equal to 1 for any angle theta. So that's a trig identity that we'll use at some point in the future. Okay, so let's also use the Pythagorean theorem to find sine of theta and cosine of theta for the angle theta equals pi over 4 radians, or 45 degrees. So if we've got a 45, 45, 90 triangle, we've got a right-angled triangle, and the other two angles are equal, they are each 45 degrees, then we know that, as always, our hypotenuse is 1. Our hypotenuse is 1, as always. That's the radius of our circle. And we know that the length of the base of the triangle is x. What about the length of the height of the triangle? In this case, it's also x, because the angles are equal, and therefore the opposing sides are also equal. So using the Pythagorean theorem, then, that means that a squared plus b squared is equal to c squared. And so we've got 2x squared is equal to 1. And now we want to get x by itself to figure out what x is equal to. X squared is equal to 1/2, dividing both sides by 2. And so that tells us that x is equal to plus or minus the square root of 1/2. X in this case is a positive value, so it must be positive the square root of 1/2, or 1 over square root of 2. Some people like to get rid of the radical on the bottom, so we can multiply by square root of 2 on the top and the bottom, and we've got square root of 2 over 2. So that is x, square root of 2 over 2, and that is also the height of the triangle because this is an isosceles triangle. And because sine of theta is y and cosine of theta is x, and in this case y, are both the same thing, that means that sine of 45 degrees, or pi over 4, is equal to square root of 2 over 2, and cosine of pi over 4 is also square root of 2 over 2. Okay, so now why don't you think about finding the sine and cosine of theta equals pi over 3 radians, or 60 degrees, as well as theta equals pi over 6 radians, or 30 degrees. So see if you can think of any trick in which you could determine the side lengths using the Pythagorean theorem for either of those two angles, and we'll talk about it together in just a moment. Okay, so there is a bit of a trick for figuring out these side lengths. We are going to start with an equilateral triangle where all sides have length 1, and that means that all interior angles for the triangle are 60 degrees, or pi over 3 radians. We're going to then take that triangle and cut it in half this way. So we're cutting that triangle in half. And now that we've cut that triangle in half, and we'll just take 1/2, it looks like that. This is still 60 degrees. Now this is a right angle, and now this is 30 degrees, or pi over 6. Now, what are the other side lengths? So one of the side lengths is easy to find. We cut this 1 in half, and so now this is just half of 1, which is 1/2. What about the other side length? We'll call that other side length y, the height of the triangle. So now by the Pythagorean theorem, we know that 1/2 squared plus y squared is equal to 1 squared. That's the Pythagorean theorem. And so 1/4 plus y squared equals 1. And now we want to solve for y. So y squared is equal to 1 minus 1/4. That's 3/4. And that tells us that y is either plus or minus the square root of 3/4. But y is a positive value in this case, so it's just positive square root of 3/4. And that's the square root of 3 divided by the square root of 4, which is 2. And great, so now we know the height of that triangle is square root of 3 over 2. So we still need to do a little bit of work to figure out what those values are, sine and cosine for those angles. But we know all the side lengths of the triangle, and so now we can just apply this using our angle theta appropriately to find those values. Okay, so we're now looking at the sine and cosine of 60 degrees, or sine and cosine of pi over 3. So sine of pi over 3 we know is the y value for that height of that triangle, and we see that the y value is square root of 3 over 2. So square root of 3 over 2 is the sine of pi over 3, or 60 degrees, and cosine of pi over 3 is the x value of that triangle. So that's 1/2. So we have those two values. That's sine of 60 degrees and cosine of 60 degrees. Now what about finding it for 30 degrees? We can just use that triangle that we've already gotten and flip it on its side so that our 30 degrees is the angle that we're interested in. So 30 degrees, and then this is still 90, this is 60, and so this is still 1/2. We're still using this same triangle. This is square root of 3 over 2, and this is still 1. And so now x and y have flipped roles. So now this is our x value, or the adjacent, and this is our y value, or the opposite angle. And so that tells us that sine of pi over 6 is equal to our y value, which is 1/2, and cosine of pi over 6 is equal to our x value, which is square root of 3 over 2. So here's a table of the values we have so far for sine and cosine. Let's do a few more. So how about theta equals 2 pi over 3? So pi over 3 is 60 degrees. That's about there. And another pi over 3, 2 pi over 3 is going one more pi over 3 over, so it's not perfect, but we'll go with it. Pi over 3, 2 pi over 3. And let's observe that there's a relationship between these two if they're drawn correctly. So note that the height of the y value is exactly the same, or should be exactly the same on each side, and the actual magnitude of the x value is also the same on each side. But if this is positive x, then this is negative x, and if this is positive y, then this is also positive y. So that means that there is a relationship between what we had for our values for pi over 3 and what we have for 2 pi over 3. As we said, the y values are identical, and the y values, that's our sine of theta. So sine of theta is the same as what we had before, square root of 3 over 2, whereas the x values are opposite of one another. So it's negative x, whatever we had before. So this was 1/2. Now we're going to have negative 1/2 for the the cosine of 2 pi over 3. Let's do one more. Let's do 3 pi over 4. So pi over 4 is 45 degrees. That's here. That's pi over 4. Pi over 2 is here. That's the same as 2 pi over 4. And 3 pi over 4 is here. 3 pi over 4. So again, we've got a situation where our triangles look pretty much the same. They're just on different quadrants of the unit circle. So here our y values are the same. Our magnitude of x is the same, but it's positive x and negative x. And so looking back at pi over 4, our sine and cosine for 3 pi over 4 are going to be, well, the sine is the y value, which again is positive in this case. So square root of 2 over 2. And our cosine is going to be negative in this case, negative square root of 2 over 2. And we could also do this for other pi over 4. This is 5 pi over 4 here. This was pi, which is the same as 4 pi over 4. And for that, we've got the same kind of triangle going. So I've still got negative x as the base of the triangle, but now the height of the triangle is negative y, or the point on the point where the triangle hits the unit circle is at negative y. So if this was the point x comma y, this is the point negative x comma negative y. So both the x and y values are going to be negative here. This is 5 pi over 4. So negative square root of 2 over 2 and negative square root of 2 over 2. And one mnemonic to remember when sine, cosine, and tangent are positive and negative is the mnemonic, all students take calculus. You're taking calculus. What a great student. And so here all of the functions sine, cosine, and tangent are positive. Here sine is positive, but tangent and cosine are negative. Here tangent is positive, but sine and cosine are negative. And here in the fourth quadrant, cosine is positive, but sine and tangent are negative. So you can keep filling in those values. You can try them out yourself. I'm not going to do them in this video, but you can easily look them up online and confirm your answers if you try these out. Let's now talk about the relationship of sine and cosine to the other four trig functions. So our other four trig functions are tangent, which is sine theta over cosine theta, cotangent, which is 1 over tangent of theta, and therefore it's the reciprocal, cosine theta over sine theta. Secant is 1 over cosine of theta, and cosecant is 1 over sine of theta. So we can use what we know so far to find any of those trig functions for any of the angles that we know or can calculate. So for example, if we wanted to find cotangent of, let's say 3 pi over 4, then that's cosine of 3 pi over 4 divided by sine of 3 pi over 4. And so that is cosine of 3 pi over 4, we know is negative square root of 2 over 2, negative square root of 2 over 2. Sine of 3 pi over 4 is square root of 2 over 2. And so when we divide, we've just got negative 1 is our solution. Let's do one more. Let's do tangent of, say, pi over 2. Tangent of pi over 2, that's sine of pi over 2 divided by cosine of pi over 2. And so that would be 1 divided by 0. And, that's the problem. We can't divide by 0. And so because we can't divide by 0, that means tangent of pi over 2 is undefined. And it's also going to be undefined anytime that cosine is 0. So tangent of pi over 2 is undefined basically for all integer multiples of pi. All places where cosine is 0, and that happens at, half integer multiples of pi. So integer multiples of pi. So for 3 pi over 2, pi over 2, 5 pi over 2, negative pi over 2, and so on forever and ever. Let's finish up just by talking about the graphs for sine, cosine, and tangent of theta. So for sine of theta, our graph is that we know that sine of 0 is 0. Sine of, let's jump up to pi over 2 is 1. So pi over 2, sine of pi over 2 is 1. Sine of pi we found earlier was 0. Sine of 3 pi over 2 is negative 1. And this is a wave function that slowly goes up and down, and it's going to do the same thing forever. It's going in multiples of 2 pi, so it repeats itself every 2 pi. And this is the graph of sine of theta. This was negative pi and negative 2 pi and so on. Okay, how about cosine of theta? Well, cosine of theta we'll draw in red because that was our x value usually. Cosine of theta starts at 1, so starts at 1. And then at pi over 2 we got 0. At pi we have negative 1. And 3 pi over 2 we're back at 0, so 3 pi over 2. And so this looks a lot like, it looks almost exactly like the graph of sine of theta, but it is shifted over by pi over 2 units. So it looks almost exactly the same. So negative pi over 2, negative 3 pi over 2, and so on. Okay, so this is cosine of theta, y equals cosine of theta. And so let's observe a couple other things about these functions. Cosine of theta is what's called an even function, and it's an even function because if we look at the negative value and the positive value for any value of x, the negative value and the positive value are equal, whereas sine is an odd function. So if we look at the negative value, negative pi over 2, and the positive value, pi over 2, they are going to be opposite. So this is 1 and negative 1. So another really important thing to notice about sine and cosine is that they are bounded between 1 and negative 1. So for all values of theta, sine of theta is less than or equal to 1 and is greater than or equal to negative 1. And similarly, cosine of theta is bounded between those two values as well. So those are some really important properties of sine and cosine. Let's now talk about tangent of theta. So tangent theta, let's graph it here. So this is equal to sine of theta divided by cosine of theta. One property we already noticed is that for every odd multiple of pi over 2, tangent of theta does not exist, is undefined. So here's pi over 2, 3 pi over 2, and 5 pi over 2. Here's negative pi over 2, negative 3 pi over 2, and so on. So for each of those odd multiples of pi over 2, tangent of theta is going to have a vertical asymptote. Tangent of theta is undefined at odd multiples of pi over 2. So tan theta does not exist or is undefined for theta equals k pi over 2 k odd. Okay, what else can we figure out about tangent? Well, we saw that sine of theta is 0 for every integer multiple of pi. So since tangent is sine over cosine, it's 0 over 1 or negative 1 in each of those cases. And so we're going to have a value of 0 for each of those. Got a little ahead of myself there. And then what else do we know? We know, using that all students take calculus mnemonic, calculus mnemonic, that for our first quadrant, so our first quadrant would be up to pi over 2, all the values are positive. So when I got ahead of myself here, drawing this function pointing upwards towards that horizontal asymptote, that's valid. What about here, this quadrant 4? Those would be, like, for example, theta less than or equal to 0, greater than or equal to negative pi over 2. That would be this quadrant right here. And so those values are negative. So if there is a vertical asymptote, then it must be going towards the negative direction. And we know, what else do we know? Let's go, like, what quadrant is this right here? This is the second, let's see, yeah, this is the second quadrant. This is the quadrant from theta being between pi and pi over 2. And so in that quadrant, sine is positive, but cosine is negative. So that means we must be a positive divided by a negative is negative. And so that's what we look like. And when we get up into quadrant 3, 1, 2, 3, when we're up in quadrant 3, tangent is positive, so it goes up like this. And basically, tangent is just going to continue over these intervals to repeat itself. We know that cosine and sine repeat every 2 pi, so tangent must as well. And this is what our graph of tangent of theta looks like.